Ladies and gentlemen, lend me your ears and maybe your spaceships, because today we're venturing into a realm where family drama meets Einstein's special relativity. We call it the twin paradox, though I prefer to think of it as that time your sibling refused to age like a normal person. Picture two identical twins, both happily growing older at the usual pace, until one decides to hop on a rocket and zip off near the speed of light. Zoom! Off they go, leaving their twin back home, where life plods along in the slow lane of normal time. Then, when our cosmic traveler returns, they're suddenly younger than their stay-at-home sibling. Yes, you heard right, the wanderer in space is now the baby-faced twin. Cue all the cries of cheater, unfair, and this was not in the brochure. But friends, is it actually a paradox or just a case of cosmic jealousy? Let's unpack it. We have two twins, Jet Set Jenny and Earthbound Eddie. At the start, they're exactly the same age. But after Jenny's interstellar joyride, she returns younger. No fancy serums, no face creams, it's just good old relativity. Wait, you might say. Relativity claims that from Jenny's viewpoint, Eddie's clock is slower, and from Eddie's viewpoint, Jenny's clock is slower. So how on Earth, and off Earth, can one twin wind up younger than the other? The trick, dear audience, is that Jenny is the one who left Earth, traveled away, turned around and came back. That pivotal turnaround is the kicker. Eddie experiences no major acceleration, he's basically floating in one consistent inertial frame. Meanwhile, Jenny's timeline has two distinct stages, the outbound journey and the inbound journey. Switching from one stage to another involves acceleration and changes in velocity. Her ride through space-time isn't one long straight coast. In special relativity, time has this wonderful stretchy quality called time dilation, which means if you're blazing along near light speed, less of your own personal time ticks by compared to someone stuck in a slower groove. But here's the real takeaway. Traveling in a straight line through space-time without detours maximizes your proper time, which is your personal experience of time passing. The moment you accelerate and change direction, like Jenny does when she flips the spaceship around, you bend that path, shaving off precious ticks from your personal clock. So while Eddie is just drifting along his own timeline, living life, paying taxes, and marking birthdays, Jenny is effectively cutting corners in the fabric of space-time. Result? She experiences less time in her journey. Let's say Jenny zips away at a speed of 0.8 CE, 80% the speed of light, for what she calculates as 5 years. Then she rapidly turns that spaceship around, cue dramatic interstellar U-turn, and comes back at the same speed for another 5 years by her clock. She's logged 10 years total from her perspective, but poor Eddie, left behind on Earth, has aged something like 17 or 18 years during that entire round trip. When Jenny finally steps off her spaceship, maybe with some cosmic souvenirs, she'll be definitively younger than Eddie. No illusions, no camera filters, just Einstein's laws doing their thing. There's no real paradox once you account for the acceleration and change of reference frames involved in Jenny's trip. Special relativity's time dilation calculations apply nicely in each leg, outbound and inbound. Handle the turnaround properly, and everything stays tidy. Nobody's breaking the universe. You can dive into general relativity if you want all the bells and whistles, just to confirm that gravitational effects or more extreme accelerations don't magically cancel out this fountain of youth in space phenomenon. They don't. The traveling twin simply ages less. So if you ever want to revisit your younger years, find yourself a near light-speed rocket. Of course, you'll come home to discover your friends and siblings have long since moved on, maybe a bigger cosmic bummer than having extra wrinkles. In short, the twin paradox is no paradox at all. Just a reminder that if you can't handle a little cosmic acceleration, you'll age at the same rate as the rest of us. And that's a wrap on your front row ticket to Relativity's most famous family feud. If anyone figures out how to build a rocket ship for cheap, do let me know. In the meantime, travel safe and don't forget to pack a calendar because time can be a tricky business out there among the stars.